Solar powered home. Okay. So solar powered home, meron tayong the three configuration. The first one is grid tied. This is the grid. A grid tied solar power system is connected to the home and to the traditional electricity utility grid. This type of power system does not include any storage battery. So yung grid tied daw is wala siyang battery. So next is off-grid. Ito naman, ito yung type na is a standalone system that is completely disconnected from the electric power grid. It contains a large set of battery packs which stores energy during the day to be used at night or at many times when sunlight intensity is low. And yung pangatlo naman is yung hybrid. Ito yun, ito naman, ito yung agreed in there's a solar power system is also connected to the traditional utility. Intertied solar power system is also connected to the traditional utility power grid, which contains battery backup. The addition of battery backup enables the system to work when there is power interruption. So ito yung process ng solar powered home. So ito si solar panels, may naka-connection na inverter, meter, and yung supply ng kuryente is napupunta sa bahay and sa electric grid. So ito yung mga basic parts. The first one is solar panel, next is grid tie inverter. May dalawang types yan, yung with or without limiter, and yung isa is yung square wave or pure sine wave. Next is yung DC circuit breaker, DC surge protection device, also known as SPD, AC circuit breaker, AC surge protection, and time delay switch, EDS, and DC or AC electrical wires, MC4 connectors, solar rails, clamps, and na-explain natin lahat yun. Next, ito yung uri ng solar panel. Okay, next. Okay. So, yung function niya is siya yung heart of solar powered home. A typical solar cell will only produce around half a volt. So, half a volt lang daw yung kaya produce ng typical na solar cell. So, by connecting them in series inside the panel, mas madami silang volt na nakukuha or naiipon. So, sabi dito, most small solar panels rated 150 watts or below are rated as 12 volts, while larger solar panels are 24 volts. Sabi pa, a 12-volt solar panel produces around 14 to 18 volts when put under load. This allows a single solar panel to charge up to 12-volt battery instantly if you connect a voltmeter reading up 26 volts. This is normal in an open circuit on a solar panel. As soon as you connect the solar panel into a circuit, this voltage level will drop to around 14 to 18 volts. Next, ito yung mga iba-ibang ayos ng solar panel. So, meron tayong panels in series, PV panels in parallel. Ayan, sila. Ayan yung mga uri ng connections ng solar panel. Next. So, ito yung example ng kung paano mo kukunin yung total power ng isang solar panel. So, ito, ang gagawin mo lang is kukunin mo yung total volts and multiply lang siya sa total current. And first one is 36 volts, tapos meron siyang 10 amperes. So, multiply mo sila. Kaya tsaka makukuha mo yung total power which is 360 watts. Ganun din sa mga susunod na example. Next. Ito yung dalawang types ng solar panel. Yung isa is polycrystalline, tsaka yung isa is monocrystalline. Ito yung polycrystalline. Tapos itong isa, siya yung monocrystalline. So, dito makikita yung pagkaiba nilang dalawa. So, ito yung mga factor na i-consider natin. First one is silicon arrangement. Yung monocrystalline daw, meron lang siya one pure silicon crystal. And while yung isa naman is many silicon fragments melded together. Tapos yung cost, mas mahal daw yung monocrystalline kaysa sa polycrystalline. Yung appearance, panels have black hue and panels have blue hue. And yung efficiency is more efficient daw yung monocrystalline panels kaysa sa polycrystalline panels. Siyempre, alangan naman, mas mahal nga yung monocrystalline. And yung lifespan naman nila is yung monocrystalline 25 to 40 years, yung isa is 20 to 35 years. And yung temperature coefficient nila, lower temperature coefficient making them more efficient in heat. High temperature coefficient making them less efficient heat. So kung mag-invest na lang tayo siguro sa solar panel sa bahay natin, mas maganda siguro mas sure na tayo sa monocrystalline solar panels. Next, ito yung solar panel types, inverters naman ito. Yan yung mga uri ng inverters. So ano nga ba inverters? So inverters converts the DC output of the solar panel into AC, which is the standard used by all commercial household appliances. Hence, the inverter output matches the voltage within the house that is coming from the grid. Okay, but traditionally, there is usually one central in a solar panel. A more recent invention has been the microinverter. Microinverter are connected to individual solar panels so that each individual panel provides a high voltage alternating current. This setup are typically used only with grid tie systems and are not suitable for systems with battery backup or grid tie systems. Though costly, they do offer some significant benefits and over more traditional central inverter. A grid tie inverter unique characteristic over the type is it automatically shut down the system when there is no power interruption. Yun yung trabaho ng inverter. So, meron tayong dalawang type ng inverter. First one is the pure sine wave and isa is modified sine wave inverter. Sabi dito, yung pure sine daw, this type output voltage in the form of sine waves. Utilities also provide sine wave output. Because of this, pure sine waves are usually needed if you're going to be tied to the grid. Typically, you'll need pure sine wave inverter for insensitive treatment as well as TVs, civil light bulbs, appliances with AC motors. And yung modified sine inverter naman daw, in pure sine wave inverters, the AC power produced by the inverter very closely matches an actual sine wave. In modified sine wave inverters, the polarity abruptly switches from positive to negative. When looking at the wave, it has a stair-step, a square pattern where the polarity is flipped back and forth. The choppy wave can negatively affect more delicate, sensitive equipment. If you have medical equipment, you need to power such as a CPAP machine, you won't able to use a modified sine wave inverter. Additionally, in many cases, you'll start with devices attached to modified sine wave inverter. The only advantage of this type over the pure sine wave is that it's much cheaper. Mas mura lang daw yung sine wave. So ito siya. Next.
So, parts and functions. Direct current circuit breaker. So, ito yung feature ni DC circuit breaker. So, ano nga ba yung functions niya? The direct current circuit breaker sometimes referred to as PV disconnects are placed between the solar panel and the inverter. So, naka-place daw siya sa pagitan ni solar panels and the inverter, or in some cases built into the inverter. So, just like the typical circuit breaker, so si direct current circuit breaker is nag-act din as an overcurrent protective device. So, short circuit on the part of solar array may produce a high voltage of current which might damage the inverter the system as whole. So, bago mangyari ito, si direct current circuit breaker is mag-act na as an automatic switch. So, disconnecting the inverter from the solar array. So, it may also serve as a manual switch if there is a needed to turn the solar power system off. So, or isolate the solar power from the rest of the system. So, magsiserve daw siya as a manual switch. So, kung kinakailangan daw na ang si solar power system is mag-off. So, dito naman tayo sa parts and function ni AC circuit breaker, and also known as alternating current circuit breaker. So, ito yung feature niya. So, the AC circuit breaker are placed after the inverter. So, yun nga, si AC circuit breaker is naka-place siya after ng inverter. So, ang pinagkaiba nila ni direct circuit breaker is yung different place nila is si DC is naka-place between the solar panel and the inverters. Pero si AC circuit breaker naman is naka-place after the inverter. So, yun nga, gaya nga ng kay direct current circuit breaker, nag-act din siya as a overcurrent protective device due to the start circuit and overloading. So, RCBO stands for residual current operated circuit breaker with overcurrent protection. So, paano nga ba nagpa-function si RCBO? So, in the RCBO type, it has added protection. So, since it can sense earth leakage current where the typical breaker cannot, it has the capability to trip when somebody touch a live wire, thus protecting the people around it. So, yun nga, yung added protection nga niya ni RCBO is once na ikaw na mahawakan mo yung live wire, is mag-auto trip na siya. So, walang masisirang system sa solar power system natin. So, napaka-safe gamitin ni RCBO kumpara sa circuit breaker lang. So, it may also serve as a manual switch if there is a need to turn the solar power system off. So, parts and function naman tayo ni DC surge protection device. So, ito si DC surge protection device. So, the DC SPD are placed parallel into the DC circuit breaker. So, naka-place naman daw siya parallel. So, SPD generally protects the system from power surge or more appropriate cold voltage transients. SPD redirects the excess power to the ground. So, si SPD daw ang redirect ng excess power from the grounds gawa nga ni transients voltage. So, in PV system, since solar power are heavily exposed in the environment, so si transient voltage is primarily caused by lightning. So, nagagawa pala si transient voltage gawa ng mga kidlat or lightning. So, either or indirectly. So, multiple interconnection within power cables is very susceptible to electromagnetically induced transients where power surge could also arise. So, si SPD yung nagre-redirect sa ground ng pinsala ni transient voltage. And si ground na yung mag-absorb ng transient voltage. So, transient voltage is the occurrence of very high voltage. So, syempre, gawa nga siya ni lightning. In a very short duration of time, around tens to hundreds of microseconds. So, napakabilis. So, exposed to the transient voltage may cause a catastrophic component damage leading to a system failure. So, sa parts and function naman tayo ni AC surge protection device. So, the AC SPD are placed parallel to the AC circuit breaker. So, gaya nga rin ni AC ni DC SPD, so nagsiserve din siya as a protections against transient voltage. But this time on AC na side naman. So, multiple equipment connection on the grid, either internal, can also be cause of electrical anomalies where power surge could also arise. So, yun yung functions ni AC-SPD like DC-SPD. So, dito naman tayo sa parts and functions ni time delay switch. So, ano nga ba yung functions nito? So, dito naman tayo sa parts and functions ni time delay switch. This can also be called as a power on delay. It delays the turning on of any electronic device for desired time interval. So, this device serves its useful purpose. So, karaniwan niya kapag brownout occurs after a brownout, when power have already been restored, there is the tendency of power surge which may damage the system if it's being turned on right away. So, to prevent this, time delay switch delay the turning on the system for a minute or even a bit more. So, sa parts and function naman tayo ni programmable timer switch. So, turning the solar power system on and off could be a vital routine which cannot be perfectly done in a day-to-day basis. So, programmable tier is a hassle-free which that is automatically turn the system on and off at your desired time. So, si programmable timer switch nga is ginagamit siya as a setter. So, for example, sa solar power system natin is gusto nyo na mag-on siya mga around 6 p.m. is mag-automatically on siya. So, kung isa-set mo naman siya ng kunyari 6 a.m. naman na mag-off siya, is pwede mo siyang iset ng ganon. So, magwo-work siya as a 6 p.m. mag-on until 6 a.m. na mag-off naman siya. So, yun yung functions ni programmable timers switch. So, solar-powered home. The net metering. So, what is net metering? Net metering allows customer of distribution utilities to install on a site renewable energy. So, not exceeding 1,000 kilowatts in capacity. So, they can generate electricity for their own use. Any electricity generated that as not consumed by a customer is automatically exports to DU's distribution system. The DU then gives a PSO credit for the excess electricity received equivalent to the DU's blended generation cost. So, excluding other generation adjustments and deduction the credit earned to the customer electric bill. So, si net metering is yung batas na nagpapaintulot na makapagtayo tayo ng renewable energy facility. So, para may pagkuhanan tayo ng kuryente. So, is net metering already available in the Philippines? So, on 27 May 2013, the Energy Regulatory Commission adopted ERC Resolution 9 Series of 2013, approving the rules enabling the net metering program for renewable energy. This resolution was published on 1 on July 2013 in newspapers of general circulation in the country and took effect 15 days thereafter. So thus, the net metering rules took effect in the Philippines on July 24, 2013. So the net metering program is available on the grid distribution system or DUs connected to the transmission grid. So what benefit will get if go into net metering? So ano nga ba yung mga benefit na to? So by generating electricity for own use, you can reduce the amount of electricity from the local DU. So makakakuha ka daw ng reduce. Makakapag-reduce ka daw ng amount ng yung electricity. So the rate of saving or avoid costs realized on electricity generated for own use is equivalent to DU's retail rate, consisting of charges for generation, transmission, system loss, distribution, subsidies, tax, and other charges. So, you also earn peso credit on any excess electricity export the DU equivalent to the DU's blended generation cost. So, excluding adjustment, the peso credit earned in then used to reduce your electric bills. So, how will DU meter my important and export energy? So, the DU may opt to install to an directional meter, one to meter energy you buy from your local DU, and the other to meter the energy you export to the DU. So the DU may at its optional install a single bidirectional meter that can meter both import and export energy if it finds it to be more economical. So the DU may also install a third meter in proximity to your RE facilities to meter its total RE generations. The total RE generation shall earn for the host DU RE certificates, which the DU can use to comply with Renewable Portfolio Standard RPS obligations. So, who are qualified to participate in the net metering program? So, DU customer who are in good credit standing in payment of their electric bills to their DU are qualified to participate in the net metering program for renewable energy. So, these customers are referred to in the rule as qualified end user or QE. So, in the case the solar power system is being installed and thus sent apply for net metering, any excess energy that is being fed to the grid will be billed to the customer. So, example, when the system is rated at 5 kilowatts and the load consumption is only 4 kilowatts, the system will have an excess of kilowatts which will be sent to grid. So this excess energy will pass through the meter, hence will be billed to the owner. So another question is there any other way beside net metering that a customer having a solar power system producing excess energy during the day and yet will not pay for it? So the answer is yes. This can be achieved by using an inverter with limiter. This device limits the power that the system will dissipate. It automatically detects the maximum power that the system can be provided without the excess being sent to the grid.
So next, punta tayo dito sa circuit connection. So, ito yung example na possible na pwede natin gawing circuit connection kapag gagawa tayo ng photovoltaic solar panel. So punta tayo dito sa wire sizing. So una ay yung TW or thermoplastic wire. It is moisture resistant and flame retardant. Ganito itsura niya sa picture. So susunod is yung THW or thermoplastic heat resistant wire. Moisture resistant and flame retardant. Yung pangatlo is yung THHN or thermoplastic high heated resistant nylon coated wire designed for specific insulation material. Temperature rating and condition of use suitable for dry and damp location. So basically ito yung isa sa magandang gamitin na wire kapag gagawa ng solar panel. So ito yung pang-apat, ito yung mga THHN or THWN2. THWN is similar to THHN except it is water resistant, adding the W into the acronym. So same lang siya nung una kanina. Pinagkaiba niya lang ito is water resistant. So THWN is rated for up to 167 degrees Fahrenheit or 75 degrees Celsius in wet environments, but its successor THWN2 is rated for 90 degrees Celsius in both wet and dry environments. So ito is yung parang upgraded type nung kaninang THHN. So basically mas maganda itong gamitin kaysa dun sa kanina. Historically, THHN and THWN were separated wires, but now you typically find their capabilities combined in the THHN, THWN2 design. So, yeah. Next na wire. Note, here's a breakdown to help make some sense of the lettering. The T stands for thermoplastic insulated cable. A, single H means the wire is heated resistant. Double H means that the wire is heated resistant and can withstand a higher temperature. So yung N naman signifies that the wire is also resistant to water. So ito pa yung isang type ng wire. Ito yung PV wires. This type is an exclusive kind of wire created for PV applications. These cables behave extremely well in very hot temperature and other harsh environmental conditions. Its special characteristic compared to other wire is its insulation and outer sheet, which is made up of XLPE or EPR. XLPE is an acronym for cross-linked polyethylene. XLPE is a thermosetting polymer, meaning that the material polyethylene is cured under the heat and in that process forms bond in all directions, forming a three-dimensional matrix. EPR means ethylene propylene rubber. So kung ating pagbabasehan yung mga naging pinasa nating mga wire kanina, ito yung pinaka-the best na gamitin dahil sa kanyang mga specification. Kaso ay mas mahal ito kaysa dun sa mga naunang wire. So ayan yung example niya. Double coated siya. Kaya maganda talagang gamitin. So punta naman tayo dito sa American wire size ng mga cable. So ito, dito natin makikita yung different wire size na pwede natin gamitin. So ito namang table na to is gagamitin natin mamaya sa pagko-compute natin ng wire sizing na gagamitin natin. Yung mga table na yan. Ayan. So ayan, punta tayo dito na sa step in PV system conductor sizing. paano ba kukumputin yung tamang conductor size na gagamitin natin. So una, step 1, look for the ISC rating of PV cell. Pangalawa, multiply by two safety factors. Yung una yung irradiance and continuous duty. Refer on table 3.10.15b16 for the size of wire. Number 4 and 5, ito when needed lang. Kapag kailangan lang siyang i-compute, saka natin ko-compute. Refer on table 3.10.15 B2A for ampacity correction due to ambient temperature more than 30 degrees Celsius. Refer on table 3.10.15 B2C for ambient temperature adjustment due to conduit or wire distance from the roof. Step 6, refer on the table 3.10.15 B3A for adjustment due to more than 3 wires inside conduit. 7, find the adjustment due to voltage drop. 8, the value obtained in the last step will be basis for the size of wire to be used in the PV system. So ngayon, kumputin natin kung anong wire ba tamang gagamitin natin. So dito na tayo magbe-base sa mga PV cell specs. Sila kukuha ng gagawin natin. Kukumputin natin mamaya. Ayan. Meron tayo ditong yung sa Jazz Solar, Jinko Solar, Suntech, tsaka sa Trina Solar. So yung napili ko is yung sa Jinko Solar. So step 1, tignan daw natin yung ISC rating. So dito sa Jinko Solar, ang kanyang ISC rating is 9.15. So ayan, 9.15 ampere, yun na yung bago niyang IPB. Sa step 2, multiply by 2 factors, yung irradiance and continuous duty. So dito sa irradiance na to, ito yung dahil nga nakabilad sa araw, pwedeng madagdagan yung init o temperature ng wire. So at sa continuous duty naman, ito yung lumalampas yung paggana ng ating solar panel more than 3 hours. Kaya sa gagawin natin is dadagdagan natin ng 1.25 times 2 kasi due to irradiance and continuous duty. So yung IPB natin na 9.15 is times natin sa 1.25 ng 2 beses. Kaya makukuha natin bagong new IPB is 14.3. So ngayon, pupunta tayo sa table 3.10.15b16 para tignan kung anong wire ang papasok dito sa nakuha natin new IPB na 14.3. So yan, kung titingnan natin dito, sa 90 degrees, gagamitin natin ay THHN. Pasok siya sa 14, kaya magiging 25. Pasok siya sa size ng 14 na wire. So, ayan. The table indicates number 14 THHN with an ampacity of 25 ampere. So, since hindi recommended yung number 14 na wire size, kaya mag-adjust tayo sa number 12 na THHN with an ampacity of 30 ampere. So sa step 4, since Philippines ambient temperature is around 37 degrees, so lampas siya doon sa minimum na nakalagay dito sa ating table. Yung allow niya lang, ito, based on ambient temperature of 30 degrees Celsius, yun lang kaya niyang i-accommodate. So lampas yung 37 degrees Celsius na heated temperature natin dito sa Pilipinas based sa Weather Bureau. Kaya mag-a-adjust na naman tayo. So pupunta tayo ngayon sa table 3.10.15b2a indicates that so hanapin natin yan kung saan papasok itong 37 degrees na ito. 3.10. So ayan. So, 37, pasok siya sa dito, 90 degrees, which is 0.91. So, ayan. yung 30 amperes natin na nakuha dito sa 12 THHN na with ampacity of 30 ampere, ita times natin ngayon sa 0.91 na nakita natin doon sa table. So, magkakaroon tayo ng new wire ampacity na 27 ampere. So, dito sa step 5, ambient temperature adjustment due to roof wire distance. So, meron na namang adjustment dahil dun sa nakadikit yung wire natin sa bubong. So, pwede na namang uminit kaya magkakaroon na naman ng dagdag na temperature. So, ngayon, pipili natin yung 1/2 in above the roof. So, check natin yan ulit sa table. Yung initial na 37 degrees ngayon, titingnan natin kung ilan ang idadagdag natin sa table. Ayan, above roof na 1.5 inch. Sa temperature adder natin is magdadagdag tayo ng 22 degrees Celsius. So, ayan. Yung initial na 37 degrees temperature natin, dadagdagan natin ng 22 degrees kaya magiging 59 degrees Celsius na siya. Yun yung magiging new ambient temperature natin. Sa table 3.10.15 B2A naman indicates that yung new wire ampacity natin na 27 degree ampere ay i-check natin ngayon kung saan napapasok itong 59 degrees Celsius. Kung ano yung magiging multiplier niya na. So ayan, 59 pasok siya dito sa 56 to 60. So, check natin yung tapat ng 90 degrees which is 0.71. Ayan. Yung 27 ampere natin na wire ampacity is multiply natin sa 0.71. Ang lalabas is 19.7 ampere. Since 19.71 ampere, 19.7 rather ampere, nagkamali lang, is greater than 14.5 ampere. Yung sinelect natin na 12 wire THN wire ay pasok sa gagawin nating system. So dito sa step 6, since there is only 2 wire inside the conduit, this step can now be bypassed. So ayan. Since dalawa lang wire na andun sa conduit natin, ibabypass na natin itong step 6. Punta na tayo sa step 7. I-adjust natin, adjustment due to the voltage drop, BD equals 3%. So ayan. Use the formula BD equals 2 IR. Yung R is equal to K L over A. So ayan, doon na tayo ngayon dito sa computation. 2 times I. Yung I na yan ay titingnan natin ulit doon sa specs ng Genco Solar. Yung maximum power current niya, which is 8.61. Ayun. 8.61 ampere. Yun. Tapos yung 12.9 given na yung value ng A. Mamaya papakita kung paano nakuha yung 12.9 na. So yung length niya, assume lang natin na 25 meters. So para makuha yung area, circular mill, punta ulit tayo sa table. Dito. Yung 25. Size 12. Size 12 na wire na gagamitin natin. Yung circular mill niya dapat is 6,530. So yun yung gagamitin nating area. So ayan. Ayun, 6,530. So kapag kinumpute natin yan, lalabas is 0.85 volts. So para makuha yung percent ng voltage drop, 0.85 divided by 32. So saan nakuha yung 32 na yun? Balik tayo dun sa specs ng Genco Solar. Ayan. Kung titignan natin dito, yung maximum power voltage niya is 32 volts. So yun, dun ang galing 32 volts. Na dinivide natin sa kanya times 100%, ang lumabas is 2.65%. Since 2.35% ay less than 3%, yung sinelect natin na number 12 THHN wire ay pasok na pasok sa gagawin nating system. So, but since 2.35% is a bit near to 3%, it would be better to use number 10 THHN for additional safety and for future expansion. So, ayan, sabi dito, kasi nga ay masyadong malapit na yung 2.35% at 3%, mas maganda na mag-adjust tayo, gumamit tayo ng number 10 na THHN para mas safe. At kung magpadagdag tayo man ng solar panel, okay, papasok pa rin yung number 10 na THHN wire. So yan, let's say yung voltage drop niya ay naging 5%. So computein natin yung number 10 THHN wire kung papasok pa rin sa ating system. So punta ulit tayo dito yung sa formula, sa problem natin yung 2, yung given, yung I natin 8.61, tapos yung K 12.9, tapos itong 25 given yung 10,380 check natin doon sa table, tapat yun ng number 10 THHN wire. Ito yung circular mill niya. So ang lalabas na value dito is 0.54. So yung pag kinumpute yung voltage drop niya, 0.54 divided by 32 volts, yung maximum voltage niya kanina, specs, times 100%, lalabas 1.69%. So, ayan, mas bababa pa rin siya sa 5%, kaya yung sinelect natin na number 10 THHN wire is the final wire na gagamitin natin sa ating system. So, next, ito yung K, sinabi ko nina. K equals to direct current constant. This is a constant representing the direct current resistance for a 1,000 circular mills conductor that's 1,000 feet long at an operating temperature of 75 degrees Celsius. The direct current constant value you should use for copper is 12.9 ohms. So, ayan. Since copper yung ginamit natin, ayan, 12.9 ohms yung kinuha nating value. And 21.2 ohms for aluminum conductors. The K constant is suitable for alternating current circuits where the conductors do not exceed number 1/0. So kung gusto naman nating mapadali yung pag-compute natin sa tamang wire, check na lang natin dito sa table. Pero since gusto nating makuha yung talagang computation niya, ay ginawa natin yung kanina. Ayan, dito lang natin i-check. Ayan. So ayan, punta na tayo dito sa inverter sizing. So, sa inverting sizing naman is for the inverter to fit the system, its power rating must be approximately equal to the power rating of the solar arrays, or maybe a bit greater of around 10% to 20%. So therefore, if your solar system is rated at 2,000 watts, you'll need a solar inverter that is about 2,000 watts. Then kung yung solar system daw natin ay nag-rate ng 2,000 watts, ang kailangan rin nating solar inverter ay 2,000 watts rin. An inverter that is way below the power rating of solar arrays cannot maximize the power that the solar arrays are capable of. And an inverter that is way above the power rating of solar arrays will be noticeable drop in efficiency. So, ayun. So, kailangan talaga is saktong-sakto lang yung gagamitin natin. O kung hindi man is may allowance lang siya na kaunti. Parang fit na fit yung magiging solar panel natin. So, sa ating example, kanina, yung Ginkgo Solar na yun is tatlong Ginkgo Solar. Ang magiging equivalent na rated power niya is 855 watts kapag pinagsama yung tatlo na yun, kasi series sila. So para ma-compute natin yung kailangan natin na inverter, dagdagan lang natin, i-adjust lang natin ng 10% para may allowance, para mas maganda yung makuha nating value. So kapag yung 885 times 1.1 lalabas is 973.5 watts. Since wala namang nabibili na inverter na 973.5 watts na eksakto, ay gagamit na lang tayo ng 1 kilowatts grid tie inverter. Pupunta naman tayo dito sa circuit breaker sizing. For this, first thing to consider in sizing a CB or for PV system is the ruling in PSC, which state that photovoltaic circuit current is continuous, thereby the minimum OCPD rating is 125% of the maximum current. So PSC 2017 Article 6.90.2.2b and Article 6.92.2.3b. Therefore, reference ulit doon sa problem in conducting sizing na ginawa natin kanina. On the DC side of the max, so pag titingnan natin doon sa spec, sa kaninang kinumpit natin, yung current niya is 14.3. So multiply lang natin sa sabi dito sa rule, ay dito sa sinabi ko kanina na 125%. So pag multiply natin, ang lalabas doon is 17.88 ampere. Since wala ulit na gantong eksaktong circuit breaker, gagamit na lang tayo ng 20 ampere circuit breaker. So dito naman sa AC side, since the inverter rating is 1 kilowatt hour, yung na-compute natin kanina, dividing this by 220 volts, kasi yun yung standard na volts na gamit natin dito sa Pilipinas, the current will be 4.5 ampere. So yung 4.5 ampere na yan, multiply ulit natin sa 125%, lalabas is 5.625 ampere. Since wala ulit yung ganyan, gagamit tayo ng 6 ampere circuit breaker or RCBO. So, since pag tignan kasi natin dito sa table, ayan. Dito natin titingnan yung table. Dito papasok yung kanina. Yung sa DC circuit breaker natin. Since malayo masyado yung na-compute natin sa AC breaker, malayo masyado sa 15, gagamit tayo ng 6 ampere since meron nang nabibiling gantong circuit breaker, AC circuit breaker dito sa atin. So, punta tayo dito sa surge protection device sizing. The rule is simple in sizing of surge protection device. Basically, the UC rating of the SPD should be match the system voltage or a bit higher, 15% to 25% for SPDs to attain a longer lifespan. Therefore, in reference to the problem in conductor sizing, so kung magre-refer ulit tayo dun sa problem in conductor sizing na kinumpit natin kanina, for the DC side, ang gagamitin nating SPD ay yung merong USC rating of 100 volts to 120 volts. So dito naman sa AC rating side, use SPD with UC rating of 230 volts to 275 volts. Since yung kanina is 220 volts ang standard, magdadagdag na tayo ng 15 to 25%. So gagamit tayo ng 230 to 275 volts na SPD. Merong UC rating na ganyan. So ito yung mga example na. So ano ba yung SPD specs? Ito yun. Yung IN equal meaning nominal discharge current. Yung Imax naman is maximum discharge current. Yung UC, ito yung kanina. Maximum continuous operating voltage o yung MCOV. Next, yung UP, voltage protection rating VPR or surge protection rating SBR or clamping voltage. So punta tayo dito sa solar panel orientation naman. On the country located at northern hemisphere, solar panels should be facing south direction for maximum sunlight. While in the southern hemisphere, it should be faced north. So since the Philippines is above the equator, belong tayo sa northern hemisphere. Thus, the solar panel should be facing south direction for maximum efficiency. So dapat dito sa atin, nakatapat yung mga solar panel natin sa south para sa maximum efficiency. A general rule for optimal annual energy production is to set the solar panel tilt angle equal to the geographical latitude. Essentially, the closer a solar panel is located to the equator, the more the panel should be pointing straight up. The closer the panel is to the poles, the more they should tilt towards the equator. Therefore, in Philippines, the solar panel tilt should be 12 degrees to 14 degrees. So, ayan yung tilting angle na kailangan ng mga solar panel natin dito sa Pilipinas para makuha natin yung maximum efficiency. So, punta tayo dito sa pag-compute ng zero bill computation. So, una is kukunin natin yung monthly average. So, kinuha ko dito yung 200 kilowatts per month. So, next, i-convert natin to sa daily usage, which is 200 kilowatts per month. Divide natin sa 30. Kakalabasan is 6.67 kilowatts per day. Convert natin sa watt per hour lang para maging pantay siya dito sa pag-convert natin mamaya ng mga watts. Kakalabasan is 6,670 watts watt hour per day. Ito note, in Philippines, peak sun hours is 5 hours. So yung peak sun hours lang dito sa atin is 5 hours. So yung nakuha natin 6,670 watt hour per day, divide natin sa 5. Lalabas is 1,334 watts. So para makompute natin yung zero bill assurance, wala na tayong babayarang kuryente, i-times natin siya sa 1.1. Yung 1,334. So ang lalabas is 1,467.4 watts. So para makuha natin yung number of panels, divide lang natin to sa 300. Kasi karaniwan na mga nabibiling solar panel is ganito yung rated niya. 300 watts yung rated niya. So kapag dinivide natin yan, lalabas 4.89. Wala namang nabibiling ganyan sa. Round up na lang natin sa 5 solar panel. So ayan, pag 5 solar panel ang ginamit natin sa 200 kilowatts hour per month na nakukonsume natin, kakalabasan magiging zero bill tayo. Pwede pang lumampas kasi nag-adjust tayo ng 10%. Nag-round up tayo dito. So yun lang po. Thank you.